Hi guys. So there is the concept of broadcasting in Numpy, which is the way of performing the arithmetic operations on arrays of different shapes without explicitly copying or looping. Numpy broadcasts the smaller array across the larger one so that they have compatible shapes for element-wise operations. So now let's see first example. I'll say here example 1, simple broadcasting with scalar, that is nothing but a single value. So for that, first thing which we need to do is import the library. So I am just importing numpy and I'll assign it to variable as np so that it will be easy for us to call. Then I'll create one array using the array function of numpy library, that is nothing but numpy.array. And to create an array, you first give this parenthesis for a function and then it's a list of values, right? So here I'll just give 1, 2, 3 and 4. I'm just taking these 4 values. Okay, now here I have created an array. So now I will take one variable, say result, where I'll be storing the result of broadcasting, say. So here I will say array. Then let's do broadcasting with some scalar values. Say here I'll take 10. So I am just adding the element wise 10 to every element in the array. So then simply I will just print the result. Okay. So now let's run this. Now, as you can see here, you got the result as 11, 12, 13, 14. So what it did was it just added this scalar. Here we have one say array like this, right? Which was what? 1, 2, 3 and 4. And then we added a 10 to it, just scalar 10. So now here you have one row but 4 columns, right? So here also you have one row. So row is fine, but you need to broadcast it along the column. So how it will do is, as I am broadcasting it along the column, it will copy the same element here. Okay. So that means now the additions is something same which we say element wise, which is nothing but this 1 plus 10 is 11. Again, this 10 plus this 2 is 12. Similarly, here 13 and here 14. So that's how broadcasting worked in your case here in a code. So this element wise addition here happens automatically. And the 10 is scalar, so it is broadcasted to shape now 4 cross 1 because the array is of shape 4 cross 1. Okay. Now let's do something as, let's take example 2, which is nothing but broadcasting here one dimensional to two dimensional. Okay, that is nothing but 1D vector to 2D vector. Okay, so that how you will do. Let me first assign the arrays. So how do we do that? Now let's assign first 2D array, right? As we want to do it for 2D. So here I am just taking A, which is nothing but creating this numpy array. This is how you create a 2D array. So list inside of a list. So this is nothing but a simple numpy array. I have created A, that is nothing but of dimensions what? 2 rows and 3 columns, right? So 2D. And then I have something called as 1D array. So here I'll take nothing but B. So this is a simple 1D array which we saw here. Okay. Now I want to add these two. So how do we do that? Element wise addition. That is nothing but A plus B, right? And then we want to print this result. Now here what will happen is A has a shape of what? 2 by 3, right? And the B has the shape of what? 1 cross 3. So now this B will get broadcast to what? 2 cross 3 array now. That means it will add each row with B. So once we do this, we can see the result. Now what happened is this whole row first got broadcasted. So now we have 2 rows with the same elements. So this multiply, this addition with this addition with this. So similarly you get the result. Now let's see one more example, that is column vector broadcasting. So that means what you are doing here is you will have A, which is nothing but an array, that is 2 cross 3 as we saw above. And then here we have B, which is nothing but column vector. Column vector means what? So this has 2 arrays and 1 column. So it just have a 1 column. This is also called as column vector. So now when we do this, say result equals to A plus B, and when we print it, now here you can see A was what? 2 cross 3 and B was what? 2 cross 1. So what happened here? NumPy broadcasts this B across columns now. So the result will be 2 cross 3 matrix as we can see here. Now let's do one more example where both are of different dimensions. That means here I will take A, which has a shape of 1 cross 3 cross 1. That means it's a 3D matrix basically with a one column. Okay. And then we have something called as B, which simply has a shape of 1 cross 3. That is nothing but 1 row, 3 columns. That is 1D. So this is 3D. This dimensions of A is 3D and dimensions of B is just simple 1D. Now when you do here results equals to A plus B and then I print results. So here you can see we get the value as 11, 21, 31, 12, 22, 32 and 13, 23, 33. So what happened here? Same. That is nothing but it just got added element wise again here. So just try it on a pen and paper for your better understanding as we saw earlier how to do it. In the link I have given in the description where I have explained it theoretically how the broadcasting works. But just take a pen and paper and try it by yourself on it. So it will be easier for you to understand. So what happened here is what NumPy automatically stretches the dimensions wherever it is necessary and then perform the element wise addition. Now let's say we take something like this where my A is of a dimensions what 2 cross 3 and where I have B which just has one row and two column. So now when I say A plus B, I get a value error here. Why is it? Because the number of columns here is not same as number of columns here. So here number of columns is 3 which is not equals to this number of columns and neither is 1. So it's not compatible. Okay. So that's why we cannot perform this broadcasting here. So always remember this broadcasting happen whenever there are some similarity in the dimensions. If not, then you'll always face the value error. So say the number of columns or the number of rows between the two array which you are trying to add or do anything should be same. So now if you see here the number of rows are 2, but here the number of row is 1 and the number of column here is 3, but the number of column here is simply 2. So none of the dimensions, none of the, say the row of A doesn't matches with the dimensions of row of B and the column of dimensions A doesn't matches the column of dimension B. That's why you cannot perform the element wise operation. Either their columns or their rows should have been matched to perform the broadcasting operation. So remember one of this is a crucial point. Now why broadcasting is powerful? It saves the memories. That means no need to copy the data. It will just broadcast it to the shape and just perform the addition or subtraction or whatever operation you want to do element wise. Then it faster vectorized computations and it's cleaner, shorter code, no loops or nothing. Okay, so that is why we need broadcasting here. That's all guys. Thanks for watching.